Hello, grade 7. How are you today? Let's continue our lesson in module 1, lesson 1, real numbers. Now, in the first class, we talked about how can we classify any real number into rational and irrational number. In this lesson, we're gonna now understand what is the closure properties in the real number system. Now, here now, what is the closure? Or what's the meaning of closure? A set of numbers is said to be closed or have closure under a given operation if the result of the operation on any two numbers is in the set, and the set is also in the set. What do I mean by that? Now, as we said before, we have a set of integers, set of rational numbers, set of whole, set of natural, set of irrational numbers. Now, if I add, as an example, let's talk about the integer numbers. Now, if we have now, let's talk about the circle of the, let's talk about now the circle of the integer numbers. Now, this is a set of the integer numbers. Integers such as -1, -2, 0, 1, 2, 4, 5, 7, and so on. Now, when I multiply a number in the integer, in the set of the integer, by a number in the set of the integer, and the result is from this set, I will say that the multiplication of the integers under multiplication are closed. Let's have examples now. Let's, as an example, take number 1. And I want to add it to 7, as an example now. I took two numbers from a set of integers. Let's add them now here. -1 plus 7 is 6. Is 6 is the result from this closed circle? Yes. So that means the integers are closed under addition. Another example now. Let's take 1 and 4 as an example. Or let's say 1 and 0. Now, when I subtract now two numbers in the set of integer, is my answer integer number? Yes. So that means integers are closed under subtraction. Now, let's talk about the multiplication now. -2 times 2. Now, -2 multiplied by 2 is -4. Am I in the set of integer? Yes. So I can say now integers are closed under multiplication. Now, let's talk about the division now. 4 divided by 5. Now, both of them are integer numbers. But if I divide them now, what did I get? I get 4 over 5. Is 4 over 5 an integer number? No. So I will say now, integers are not closed under division. The integers are closed under addition, subtraction, and multiplication only, but not under the division. This is the meaning of closed that I have, that I need to take two numbers from this set, and the answer must be inside this set, it's inside this closed circle. If it is in this closed circle, yeah, it will be closure. If it is not, it will be not closure or not closed. Let's have now another example. Here now, as I told you before, integers are closed under addition, subtraction, and multiplication, such as -120 is an integer. added to 50, which is an integer, and the answer is integer. Here, -2 minus -5. This is an integer. And 4, which is an integer, multiplied by -6, the answer is an integer. But look at the division. As I told you before, integers are not closed under the division. Like -24 divided by 14. The answer is -1 and 5/7. This is not an integer number. So I will say that integers are not closed under division. Look at the second one now. 15 divided by -6. This is an integer. This is an integer. But is the quotient is an integer? No. So I will say now integers are not closed under the division. Now, in this activity here, you will explore the closure property with the rational and irrational numbers under addition. Here, you have rational examples of rational and irrational. And I want now to explore the closure property. If I add a rational with rational, is the answer rational? Is it closed? Or it's irrational, it's not closed? Let's see here now. Now, let's classify this number here, 1/4. It is rational, because I can write it as an A/B. 0 is irrational. Square root of 3 is irrational. And negative square root of 3 is irrational, because the answer is not terminating, not repeated, and cannot be written as an A/B. Now, what about 1/4 here? Let's repeat them here now. 1/4 is rational. 0 is rational. Square root of 3 is irrational. And negative square root of 3 is irrational. Now, let's now add each number here, like from the row and the column, like 1/4 plus 0. What's the answer will be? It is 1/4. No. 1/4 and 1/4 it's 1/2. Okay, now 1/4 plus square root of 3, it's 1/4 plus square root of 3. 1/4 minus square root of 3 is gonna be 1/4 minus square root of 3. 0 plus 1/4, 1/4. 0 plus 0, 0. 0 plus square root of 3, square root of 3. And 0 plus negative, it will be negative square root of 3. Now, square root of 3 plus 1/4, it will be 1/4 plus square root of 3. Square root of 3 plus 0, it will be square root of 3. Square root of 3 plus square root of 3, it will be 2 square root of 3. And square root of 3 minus square root of 3, it will be 0. Now then, negative square root of 3 plus 4, it will be 1/4 minus negative square root of 3. Negative square root of 3 plus 0, it will be negative square root of 3. Negative square root of 3 plus square root of 3, 0. And negative square root of 3 negative minus square root of 3, it will be -2 square root of 3. Now, one of you say, teacher, how can I add the two square roots? Like this is like negative x, and this is like negative x. When you add negative x minus x, the answer is -2x. So it's the same here. When you add negative square root of 3 minus square root of 3, replace this with x. So it's gonna be -2x or -2 square root of 3. Now, let's come back now here. Here now, so when you add rational with rational, what the answer is? Rational. So That means it's closed here. Now, rational with rational, it's 1/4, which is rational. So it's closed. Now, irrational with rational. Well, the answer here, it's irrational. So it's not closed. It's not inside it. Now, irrational plus rational. It's also not closed. Now, rational with rational here, we say that the answer is rational, so it's going to be closed. Rational with rational, it's closed. Now, irrational with rational, it is irrational. So it's not closed. Or let's classify them now like before that, closed or not closed. Let's say that if they are rational or irrational. This is better for you first to understand. So then now here, let's repeat. We said here that it is rational. The second one here, rational plus rational is rational. Here it is irrational. Here it is irrational, as we said before. Now, rational with rational, the answer is rational. Rational with rational, the answer is rational, as you see here. As you see here now. Now, irrational with rational, the answer is irrational. Now, irrational with rational, the answer is irrational. Now, rational with irrational, the answer is irrational. Rational with irrational, the answer is irrational. Irrational with irrational, the answer is irrational. And irrational with irrational here, the answer is rational. So sometimes, as you see, if you add two irrational numbers, the answer could be rational. Now here, rational with irrational, is it irrational? Rational with irrational, it is irrational. Now, irrational with irrational, the answer is rational. And the last one here, it is irrational. Now, let's summarize what did we say. Now, one of the questions now I want to ask you about. If you add now rational with rational, what the answer will be? Rational. Let's see here, rational. Rational with rational, rational. Rational with rational, rational. So that means here the summation of two rational numbers is always rational number. Now, what about rational with irrational? Rational with irrational. Rational with irrational. Or here, what about the all of them are what? Are irrational. So when you add rational with irrational, the answer is irrational. Now, what about added two irrational numbers? Like this one added to this one. The answer is irrational. But irrational with other irrational, it is rational. So that means when you add two irrational numbers, the answer could be rational and it could be irrational. So let's now summarize. Adding two rational numbers is always rational. Adding two irrational numbers, the answer sometimes could be rational, but adding irrational with rational, the answer never be rational. Let's write them here now. Now, the sum of two rational numbers is always or never, or sometimes rational. It's always, yes. Now the second one, the sum of rational and irrational numbers is never ever be a rational number. And the sum of two irrational numbers is sometimes, as we see before, sorry, let's put them here, is sometimes rational number. Now, the table shows the types of numbers that are closed under each operation. Here, when you added two rational numbers, okay, it will be rational. It's closed. So that means the rational number are closed under the addition. The rational numbers are closed under subtraction. The rational numbers are closed under multiplication and under division. Now, when if you say, teacher, like 22/7, this number here, this is rational, and this is irrational. And when you divide them, you get a rational number because it can be written as A/B. So that means it's closed. It will be rational too. Now look at the irrational. The irrational is not closed under addition. Not closed, it means sometimes rational and sometimes irrational. Like as we see before, 3 square root of 3, sorry, plus negative the square root of 3, it's 0. It is rational. But if you add the square root of 3 plus 2, it's still irrational. That's why it's not closed. At the same for the subtraction, for the multiplication, and for the division. For the division, sometimes I can say square root of 2 divide by square root of 2, which is 1. So when you divide two irrational numbers, the answer is rational. And sometimes when you divide two irrational numbers, it is still irrational. That's why I say not closed, or it means, or some can say sometimes rational and sometimes irrational. But for the real numbers, it's closed under the addition, under subtraction, under multiplication, and under division. What are the mean real numbers? They are the rational and the irrational. Means when you add the square root of 3, which is irrational, plus 3, now when you add them here, the answer is irrational, but it's real because this number is from the real number because it contains an irrational and irrational. So adding two numbers and under the real will be closed. Now, given that 2 is rational number and the square root of 2 is irrational number, identify each expression as rational or no. Here they give me two numbers now. They say that if you add them, 2 plus square root of 2, is it rational or irrational? 2 plus square root of 2, it will be irrational. Why? Because this summation here, the answer, when you write the summation, it's because the summation cannot be written in the form of AB. You cannot write it. That's why when you add rational with irrational numbers, the answer will be irrational. Now, What about now subtraction here? Here we have rational minus irrational. What the answer will be? It's still 2 minus square root of 2. So is this one now rational or irrational? Yeah, it's irrational. Why it's irrational? Look at it now. Can you now write it as an A over B? No. So we can say here now, cannot. Now look at C. Add them together. What the answer will be? 2 square root of 2. So it is still irrational. So adding now 2 irrational numbers, the answer will be irrational. Because the products cannot be written in a form of A over B. Now, let's talk about the division now. If you have now 2 square root of 2, divide by 2. 2 cancel 2, so the answer is square root of 2. So when you're dividing now an irrational number, interrational, what the answer will be? It's irrational too, because the answer here is a square root of 2. So irrational, because the quotient cannot be written in the form of A over B. Now look at B here. The sum of 1 plus square root of 2 and 1 minus square root of 2 is 2. So what does it mean? When you add them now together here, they told me that like if you add 1 plus square root of 2 plus 1 minus square root of 2, they cancel each other. So you have only, the answer is 2. So here, 1 plus square root of 2 is irrational. And 1 minus square root of 2 is irrational. But when you add them together, the answer is rational. So what does it mean? That the irrational number are closed under addition, or the irrational number are not closed under the addition, or the rational number are closed or not closed. Now we are talking about irrational, so it could be A or B. As you see here now, they are not closed, they are rational. So this will be now the correct answer here. The irrational numbers are not closed under addition. Now, B, no, sorry, F here. What does the equation 0 plus 2 square root of 2 equals square root of 2 support here? Now here what do we have? We have rational and irrational. And the answer is irrational. So what does it mean here? Does it mean that the rational numbers are closed, or the irrational numbers are closed under addition, or the sum of rational and irrational is rational, or the sum of rational and irrational is irrational? The sum of rational and irrational is irrational, as we see here, because here you added a 0, which is rational, plus square root of 2, which is irrational, and the answer will be irrational. Now G, if you divide any irrational number by itself, like square root of 3 divided by square root of 3, what the answer will be? It will be 1. So here, what does it mean? Here that means if you divide any irrational number by irrational number, the answer is rational. So That means the irrational numbers are not closed under the division. Why? Because look at the answer here. It's 1. It's rational. So it's not the same set or the same circle of the irrational. So that means it is not closed. Now at here, this is page 8, okay? Explain why the sum of rational and irrational is a real number. Let's look at this example here. Like 5 plus square root of 3. The answer is 5 plus square root of 3. So this is Anna real. Irrational. This is an irrational. So if you are talking about rational with irrational, the answer is irrational. But let's talk about it now if it is real or not real. But the first number here, is it real? 5 is a real? Yes, because it's rational. And is the square root of 3 is a real? Yes, because it is irrational. And the answer here, is it a real? Yes, it is real because it is irrational. So the sum of a rational and irrational number is a real number. Why? I will write here the explanation because, or give a counter example. I give you a counter example. So let's write here true. All rational and irrational numbers are real numbers. This is here the reason why. That's it. Now tomorrow we will solve page number 9, check understanding, and in your own, let's talk more examples to check your understanding. Thank you for listening. Have a nice day.